In the world of concrete structures, slab column connections are the unsung heroes. They transfer loads, hold everything together, and ensure stability. Imagine a building as a giant puzzle, with slabs forming the floors and columns acting as the supporting pillars. The connections are the interlocking pieces that keep the puzzle from falling apart. These connections are critical for transferring the weight of the building, along with any occupants or furniture from the slabs to the columns and then down to the foundation. A well-designed connection ensures that the forces are distributed evenly, preventing stress concentrations and potential failures. However, these connections can also be points of weakness if not properly designed and constructed. This is especially true when different grades of concrete are used for the slabs and columns, which is a common practice in modern construction. You might wonder why use different concrete strengths in the first place. It's all about efficiency and cost-effectiveness. Columns carry a much heavier load than slabs. They need to be stronger to bear the weight of the entire structure. High-strength concrete is used for columns. This allows for smaller column sizes, maximizing usable floor space. Slabs, on the other hand, experience less stress. They can be made with lower-strength concrete, saving on material costs without compromising safety. While using different concrete grades makes sense economically, it introduces a critical challenge, ensuring a strong and reliable connection between these two materials with different properties. When a slab made of lower-strength concrete meets a column made of higher-strength concrete, it's like joining two pieces of a puzzle that don't quite fit. This mismatch in strength can lead to several structural issues if not addressed properly. One major risk is punching shear. Imagine pressing down on a cookie with your thumb. The cookie might crumble around your thumb due to the concentrated force. Similarly, the column can punch through the weaker slab under high loads. Another concern is bond slip. This happens when the steel reinforcement bars inside the concrete don't adhere properly to the surrounding concrete. This lack of bond can cause the connection to weaken and potentially fail. Finally, there's the risk of progressive collapse. This is a domino effect where the failure of one connection triggers a chain reaction, leading to a catastrophic collapse of a larger part of the structure. Fortunately, engineers have developed effective solutions to address the challenges posed by different concrete grades in slab column connections. One such solution is the concrete patch technique. This method involves creating a transition zone between the slab and the column using a higher-strength concrete mix. Think of it as building a bridge between two islands. The concrete patch acts as this bridge, ensuring a smooth and gradual transfer of load from the lower-strength slab to the higher-strength column. This technique effectively mitigates the risks of punching shear, bond slip, and progressive collapse. The concrete patch reinforces the connection, making it more robust and better equipped to handle the stresses and strains of the building's load. This method is particularly effective in reducing stress concentrations at the critical junction between the slab and the column. Section 5, Step by Step, Applying the Concrete Patch. Implementing the concrete patch technique requires precision and adherence to best practices. Here's a simplified step-by-step guide. First, preparation is key. Begin by roughening the surface of the column where the patch will be applied. This creates a better bonding surface for the new concrete. Next, formwork for precision. Install formwork around the column head to contain the concrete patch and ensure its desired shape and size. Cleanliness is crucial. Thoroughly clean the prepared surface to remove any debris, dust, or loose particles that could hinder proper bonding. Now, applying the patch. Carefully pour the higher-strength concrete mix into the formwork, ensuring it fills the entire space around the column head. Lastly, curing for strength. Allow the concrete patch to cure properly. This is a critical step that allows the concrete to gain its full strength and durability. By following these steps diligently, construction teams can create a strong and reliable connection that effectively bridges the gap between different concrete grades. be made before a complete collapse occurs. Section 8. Pro Tips: Secrets to Long-Lasting Connections. Here are a few additional pro tips to enhance the longevity and reliability of your slab column connections. Roughen up. Don't underestimate the importance of surface preparation. The rougher the surface of the existing concrete, the better the new concrete will bond, creating a stronger connection. Vibrations are your friend. Use a concrete vibrator during pouring to eliminate air pockets within the concrete patch. This ensures a denser and more durable connection. Curing is key. Don't rush the curing process. Allow the concrete patch to cure properly for the recommended time to achieve its maximum strength. Consult the code. Always follow local building codes and regulations, as they often specify requirements for concrete patch design, materials, and installation. By incorporating these tips, you can ensure that your connections are built to last, providing a safe and stable structure for years to come. Section 9. Building for Strength, a Safer Future. Slab column connections are the unsung heroes of structural integrity. Understanding the challenges posed by different concrete grades and implementing solutions like the concrete patch technique is crucial for ensuring the safety and longevity of our buildings. By prioritizing proper design, quality materials, and meticulous construction practices, we can create stronger, more resilient structures for generations to come. Remember, a well-connected building is a safer building.